Hello, I'm Shazana U2101213, and today I would like to discuss about the Mercury's perihelion Precession, which is the title of a case study written by Frigola Oriol. Before we dig into a deeper context, let's see what is precession. So, Mercury moves around the Sun on its elliptical orbit, with the closest point to the Sun, which we call as perihelion, its shape of a sun. So this motion we call as precession. So the total observed of the precession of Mercury's orbit was 5,600 arcseconds per century, and most of the factors that contribute to this precession have been explained by Newtonian mechanics. 5,030 arcseconds per century is due to the precession of the equinoxes. This is a phenomenon where the Earth's axis wobbles like a spin, and it affects the reference frame that we usually use to measure the planetary positions. And 530 arcseconds per century is caused by the gravitational perturbations due to the influence of other planets such as Earth or Jupiter on the Mercury's orbits. However, there is 43 arcseconds per century, which remains unexplained by Newtonian mechanics. In 1859, Urban Le Verrier calculated the precession of the Mercury's perihelion using Newtonian mechanics. However, the result doesn't match with the observation. So he hypothesized that there is planet exists between the Sun and Mercury, and the precession is a result of the gravitational influence of this planet on the Mercury's orbit. This idea was inspired by his previous success in predicting Neptune's existence through its gravitational influence of Uranus. However, when the astronomers looked for this planet during the solar eclipse, there is no planet observed, so his hypothesis was rejected. In 1915, Albert Einstein proposed his theory of general relativity, where it describes that gravity as a curvature of space-time caused by mass. So this theory predicts that the additional precession of the Mercury's perihelion is due to the Sun's gravitational influence. So the precession of the Mercury's perihelion is a result of the curvature of space-time occurs near the Sun, which perturbs the Mercury's orbit. And this correction is precisely matched with the remains unexplained precession by the Newtonian mechanic, which is 43 arcseconds per century. Thus, this theory is confirmed and valid. So this is how the curvature of space-time in the universe looks like. To get a more clear view, let's imagine that a bowling is put at the center of the trampoline, and when we roll a marble near the edges of the trampoline, it will move towards the center spirally, and this is actually how the gravity works. So in universe system, the Sun bends the fabric of the space-time, and the planets will move around the Sun along this curve. So many more examples that prove this theory, including the black holes, where the black hole is a massive object and it wraps the space-time into deep and creates an inescapable holes even for light. The relativistic perihelion shape arises from the additional terms in the Schwarzschild metric. The Schwarzschild solution based on the spherical spaces is expressed by the line element, as I stated on the slide, and the formula of the precession is given by 6 pi times the solar mass over the semi-major axis of the Mercury's orbit. And this is a calculation to prove the residual precession. The implications of the study is to understand the gravitational phenomenon beyond Newton's theory, highlight the necessity of the relativistic corrections in describing high precision orbital mechanics, especially for the objects in strong gravitational fields like Mercury. In terms of broader impact, this study inspired the further tests of general relativity, including gravitational lensing and time dilation experiments, and it also established a foundation for modern astrophysics and cosmology, influencing studies of black holes, gravitational waves, and dynamics of galaxies.